Word equations are one of the simplest ways to express a chemical reaction. Reactants are on the left, with an arrow that shows the transformation to products, which are on the right. Another type of equation that has a similar setup is a formula equation. These are the same, apart from the names of the compounds are replaced by their chemical formula. This allows us to see with more detail what is going on in the reaction, because we can see how the makeup of the compounds change. When writing a formula equation for a reaction, it is essential that it be balanced. These equations are balanced when there are the same number of each type of atom on both sides of the arrow. Here's an example that we can balance. So we're going to always start with noting down how many there are of each atom on both sides to begin with. Next, we can start adding big balancing numbers in front of the compound names to change the number of atoms on each side. If you have a standalone element like oxygen here, you're going to leave this till last because you can change it however you like and it won't affect any of the other elements. So we're going to start by adding a 3 in front of this carbon dioxide. That means we're going to get 3 carbons here and 6 oxygens down here. Next we're going to make this 4 waters. We get 4 oxygens there and 8 hydrogens there. Next we're going to make this 5 and we're going to get 10 oxygens there. So now you can see that the number of carbons is the same on both sides, the number of hydrogens is the same on both sides, and the same for oxygen, and there's our final equation. When you come across an element on both sides, but on one side it has a subscript 2 and on one side it has a subscript 3, you need to be thinking that the lowest common denominator for these two numbers is 6. So you're going to have at least 6 on both sides. But I'm going to show you what I mean with this example. So if we note down how many there are of each element, we're going to start by putting balancing 2 here. So we're going to get 2 aluminiums and 6 chlorines. Now to get 6 chlorines on this side, we can add a balancing 3, 6 chlorines, and aluminiums by itself. So that's fine, 2 aluminiums, and here's our final equation for that.